This is Sakshi, and I welcome you all to my EduTech platform, Way to Learn. So, in my last video, we solved series of questions from differential equations, and its continuation is the special functions. So, we are going to solve the PYQs of special functions, which is a part of differential equation. So, let us solve the question. And before that, if you haven't subscribed my channel, please click the subscribe button and also hit the bell. So let us see the question now. First question, which is from June 2011, where Pn of x is given, which is a polynomial of order n with real coefficients defined in the interval 2 to 4. And if Pm of x, Pn of x, dx is equal to del mn, then. So this is somewhat the orthonormal property, and I can say that Pm of x and Pn of x are some polynomials, okay, which is satisfying this particular integral equation. Okay, I can say that this integral equation is an orthonormality condition. Okay, so when delta mn is equal to, when m is equal to n, delta mn will be equal to 1, and when m is not equal to n, delta mn will be equal to 0. Okay, so the first thing how to solve this question is, we do not know anything about Pm and Pn, that is the polynomials. So what do we do now? We have to choose from the options. Which option is the correct option which satisfies this condition? So your homework will be to solve all these options and find the correct answer, whereas over here I'll be solving the correct answer alone. So please have a look into the correct answer, how to solve the particular question, and then in your homework while practicing you are going to solve for option A, option B and option C, and see if any of these option 2 satisfies this condition or not. I can also be wrong. So better you just see if option A, option B and option C satisfies or not. I'm going to solve for option D over here. Okay. So here P naught of x is equal to 1 by root 2 and P1 of x is equal to root 3 by 2, 3 minus x. Now we know that 2 to 4 P naught of x, P1 of x will be equal to delta mn. Okay, so when m is equal to n, then delta mn will be equal to 1. And when m is not equal to n, delta mn will be equal to 0. So first we will have to see if they satisfy or not. So now here m is not equal to n. So this RHS should be equal to 0. Let us see if the RHS is getting 0 or not. The P naught of x is 1 by root 2 into root 3 by 2, 3 minus x, integral 2 to 4. So I am going to write this as 3 root 3 by 2, integral 2 to 4, 3 minus x dx, which will give me root 3 by 2 into 3x minus x square by 2 at 2 to 4. So on solving that, I am going to get 3 by 2 into 3 4 is 12 minus 6 is 6 minus 16 by 2 minus 4 by 2, which will be 12 by 2, which is root 3 by 2 into 6 minus 6 is equal to 0. So it satisfies the first condition. Let us see if this satisfies the second condition, that is P naught of x and P naught of x should be equal to 1. So P naught of x is 1 by root 2 into 1 by root 2 into dx 2 to 4. So which will be 1 by 2 dx 2 to 4, 1 by 2 x 2 to 4 will be 4 minus 2, which is 2, 2 by 2, and this satisfies. Let us see if P1 of x and P1 of x satisfies, which is 2 to 4 root 3 by 2, 3 minus x, again into root 3 by 2, 3 minus x dx, which will be equal to 2 to 4, 3 by 2 into 3 minus x the whole square dx. Okay, so I am going to use a minus b the whole square. So on simplifying, I get 9x 2 to 4 plus x cube by 3, 2 to 4 minus 6x squared by 2, 2 to 4, which will give me 3 by 4 into 18 plus 56 by 3 minus 36, which is equal to 3 by 4 into 56 by 3 minus 18. So which will be equal to 1. Basically, this will be equal to 1. You can just check this. So option D will satisfy. You will have to see for option A and option B and option C. See if any of these polynomials satisfy or not. Okay. So let us see the second question from December 2011. We have a generating function f of x comma t, which is summation n is equal to 0 to infinity t n of x t power n, and again the same generating function is equated to, I can equate these both function as equal to one another. So 1 minus 2xt plus t squared the whole power minus half. You can see this when you learn the generating function for legenda polynomials. Okay, so we'll have to find the value of p3 of minus 1. So for p3 of minus 1, see that x takes the value minus 1. So summation n is equal to 0 to infinity. P3 n is 3 and this one is minus 1. T power 3 is equal to 1 minus 2 into minus 1 will give you plus 2t plus t square the whole power minus half. So now we'll have to see that this is equal to 1 plus t the whole square power minus half. Okay, so I can say that summation n is equal to 0 to infinity p3 of minus 1 t cube will be equal to 1 plus t square the whole power minus 1. The 2 and 2 will get cancelled and I'll get the whole power minus 1. So I can just expand using the binomial expansion. So on expanding this, I get equal to 1 minus t plus t square minus t cube plus t power 4 and so on. Now we need p3 of minus 1, right? So I can equate coefficients of t cube. So p3 of minus 1 will be equal to minus 1. The coefficient of t cube here is minus 1. Hence I get p3 of minus 1 equal to minus 1. But one more thing you can remember from the property is pn of minus 1 will always be equal to p minus 1 the whole power n. So here p3 of minus 1 will be equal to minus 1 the whole power cube, which is minus 1. Very easy and simple trick. Just you have to remember this. Okay, so let us see the third problem of the day. Here the graph is given and we have to find which function satisfies this graph. Okay, so now I'm going to draw a few graphs over here and we are going to check which satisfies. Okay, so now if I do that, I'm going to draw the cos x graph. So 0 plus 1, this is minus 1. Okay, so this is cos x graph. And now I am going to draw the e power minus x cos x graph because the option third is e power minus x cos x. So when I draw that graph, you have to remember these kinds of graphs. Just we usually see many diagrams like this, many graphs like this in many photos. So please remember this. This is e power minus cos x graph, and cos x by x graph will be like okay. So this is cos x by x graph, and next is the Bessel function, which will be like, I think this is the Bessel function j1 of x, solution of first time. You can check any book, you'll have these graphs in that. So option A satisfies given figure. So I hope you like the solution, you understand the solutions. So thank you. Like my videos, share my videos, subscribe my channel, and do not forget to hit the bell. See you tomorrow with more problems. So, ta-da!